All right, so this next chapter is going to be all about sequences and series and some more financial stuff, dealing with interest, depreciation, and that kind of thing. So our first little unit here, we're actually going to quiz on sequences and series. So we're going to start off with arithmetic sequences and series. So this is something that you've seen before, either in Algebra 2 or in Pre-Cal. And first thing you need to know is actually what is a sequence. So a sequence is a set of quantities that are arranged in a definite order. So you have, this is the first number, the second number, the third number, and there's going to be some kind of pattern to that sequence. A series is the actual sum of a sequence. So if they ever ask you to evaluate a series, that means they actually want you to find the sum. Now, an arithmetic sequence, which is what we're going to start off with, this is a sequence in which each element after the first is obtained by adding, and that's kind of important. It's always adding a fixed number, which is called the common difference to the previous element. So I'm going to add 5, add 5, add 5, add 5 kind of thing. Now, a geometric sequence, that's a sequence very similar, in which the first element, in which each element, after the first is obtained by multiplying the previous element by a fixed number, and this is called the common ratio. So kind of like the common difference, this is one that is always multiplied. So if your numbers are multiplied really by or half as much each time divided by 2, then your common ratio would be a half. But we'll get to those more tomorrow. So I'm not really sure why. Actually, I do know why. I transferred this from a PDF to a Word document. So kind of right smack in the middle there, it says formula to find the nth term. We'll actually get to that in a second. The terms, though, of a sequence are generally labeled U sub 1, U sub 2, U sub 3, U sub 4. Now, it's possible in Algebra 2 or in Pre-Cal you used A sub 1, A sub 2, and so on. It's exactly the same thing. Some books use U and some books use A. All the way up to U sub n. Now, U sub n is some kind of generic term. It could be the 5th term, could be the 7th term, could be the 27th term. But that nth term is in the sequence, like I said, is called U sub n. Okay, now, so the formula to find the nth term, if I want to find the 20th term in a sequence, I can write a formula to do that. This formula is given to you in the formula booklet, and it looks exactly like that. It's labeled the nth term of an arithmetic sequence. U sub n is that nth term, so if you want to find the 10th term, then that n is going to be a 10. U sub 1 is the first term, n is the number of terms, and then d is that common difference, again, what you're adding each time. Okay. So, first question here, and you have a couple of these in your homework, is the sequence 9, 12, 15, 18 an arithmetic sequence? And then part B, find the 8th term of the sequence described in part A. Now, it's very possible that you could have a sequence that does have a pattern, it's just not an arithmetic sequence, so don't let part B make you think, oh, well, the answer to part A must be yes, because otherwise how would I have a part B? It is actually yes, but because it does have a pattern where we're adding the same thing each time. Now, it should be pretty obvious in this case that your D is 3. I'm adding 3 each time. If it's not so obvious, or you do have a question that's a little bit more abstract in your homework, you can find that common difference by subtracting 2 terms that are next to each other. They don't have to be the first 2, just any 2 terms that are next to each other. Now, find the 8th term for the sequence described in part A. So in order to find the 8th term, if we use our formula, which you do need to be able to use these formulas. I am going to show you some ways you can use the calculator, but the calculator is really going to be used for checking your answers. They're going to want to see you using these formulas. So to use this formula up here, I need to know my first term. So that would be 9. And we're dealing with this sequence of numbers here. My common difference is 3. And if I want to find the 8th term, that means that my n is 8. And I'm looking for U sub 8. So that's going to be U sub 8 is equal to 9 plus 8 minus 1 times 3. And you know how much work you show here is up to you, but again, I'm using the formula up here at the top. U sub 8 is equal to 9 plus 7 times 3. So that would be 9 plus 21, which means U sub 8 is 30. And, and then see if that makes sense. If you somehow end up with a negative answer, that doesn't make sense. So maybe something there has gone wrong. Okay. Next, the 15th term is 45. If the first term is negative 11, find the common difference. Okay, so in this case, they want to know what am I adding each time, but I don't have terms that are next to each other. So I'm going to write down what I know. I know the first term is negative 11. I know that u sub 15 is 45. Now here again is my formula. Okay, now in this case, to find the 15th term, the 15th term was 45. I would take my first term. I would plug in 15 minus 1, and then I would multiply times that common difference. Well, I don't know what it is, but I know everything else, so I can go backwards and solve for d. So 45 is equal to negative 11 plus 14d. So 56 would be equal to 14d, and d is 3. Now, there are some other ways that you could reason that out, and that's fine, as long as you're showing work and not just randomly having the 3 there. Okay. All right, next, we have a sequence 15, 11, 7, find the 20th term. Okay, so we had one similar to this up above. I just wanted to remind you that your d value is always what you're adding. So in this case, we're subtracting 4 each time, but that my d value is going to be a negative 4. And my first term is 15, and my n is 20. So 15 plus 20 minus 1 times negative 4. So 15 plus 19 times negative 4. And that would give me negative 61. So u sub 20 is negative 61. All right, now this next one here is a little bit more complicated, and it's a pretty typical kind of question. So an arithmetic sequence has a 7th term of 16.5, a 12th term of 24. Find the 24th term. Well, to find the 24th term, I need the first term and I need the common difference. And I don't know either of those two things. So I'm going to start off with the information that they've given me here. So u sub 7 is 16.5, and u sub 12 is equal to 24. Now, there are lots of different ways that we can do this question. What I'm going to do is right now I'm going to pretend, and this is the way that they do this in your book, I'm going to pretend that the first term is actually u sub 7. And then I'm going to figure out the difference between the two. And I tell you what, I'm saying this because this is the way the book does it, but I really don't like it this way. So let me show you more than one way to do this. So this is the book's method. So I'm going to kind of pretend that this is actually u sub 1. So if that's u sub 1, okay, going from term 7, let's make 7 be 1. So 8 would be 2, 9 would be 3, 10, 11, 12. So u sub 6 would be 24. So let's plug that into the formula. We can find out what d would be, and then we can go backwards from there. So u sub 6 is u sub 1 plus 6 minus 1 times d. In this case, 24 is equal to 16.5 plus 5d. And we end up with d is 1.875. Now, I can go backwards to find my first term. And by going back to that original equation, but this time let's actually plug in a for real u sub 7 or a u sub 12. It doesn't really matter which one that you do. So let's say u sub 7 is u sub 1 plus 7 minus 1 times d, which I can go ahead and put that in there. U sub 7 was 16.5. And we end up with our first term is 3.375. So now once I know my d and once I know my first term, I can figure out the 24th term there pretty easily. Now, u sub 24 turns out to be 46.5. But I want to show you another way of doing this, okay? So what if we write a system of equations, okay? So u sub 7 is u sub 1 plus 7 minus 1 times d. U sub 7 was 16.5. Okay? And then now do the same thing for u sub 12. U sub 12 is the first term plus 12 minus 1 times d. So u sub 12 was 24 is equal to u sub 1 plus 11d. Now, what I can do is I can take this system now and solve it pretty easily using either substitution or using elimination. I'm going to use elimination. 16.5 is u sub 1 plus 6d, and then 24 u sub 1 plus 11d. Now, what I'm going to do actually is I'm going to subtract those two. Now, subtraction is dangerous, so what I'm actually going to do is I'm going to go through here, and I'm just going to change all the signs. So that's going to make that be a minus. And I end up with, I need to redo the math here because I didn't do it this way on my paper. 16.5 minus 24. Didn't want to do that one in my head. Negative 7.5. Okay, the u sub 1's cancel out, and I end up with a negative 5d. I've got some, I'm sorry. I'm looking back here noticing that I put something in wrong here. Well, I'll go back and fix that in a minute. 7.5 divided by 5. Yeah, I've got the wrong d value. I've got to go back and fix this here. So d is 1.5. All right, the problem is the math I had written down on my paper was wrong. Let me, just a second. Actually, I'm just going to pause this for a minute. Okay, let's go back to when I did this the first time. The d is 1.5. The problem is when I worked this out on my paper, I made a mistake and I just copied. I did it a little bit of a different way and then copied it down wrong. So back over here, if you actually do this math, the math that I have written down is right. If you subtract 16.5 and then divide by 5, you end up with 1.5. So that's going to change this right here. And then that's going to change your first term. So 1.5. And then your first term turns out to be 7.5. Let me just verify that again here real quick because I don't want to mess up again. Yeah. So that changes our 24th term, which we'll fix that here in a minute. Okay, so now that we have our d is 1.5, now I can go back and I can set it, I can put it right here and figure out what my first term is. You could just go backwards, but you got to go backwards a lot of times. I would have some type of process to figure out what that first term is. So we can either plug it in, like I said, into this formula right here, or we can plug it back, actually do it like we did the first time around and say, hey, u sub 7 is u sub 1 plus n minus 1 times my d value, and then plug them in. So anyways, you end up with still that u sub 1 is 7.5. Let me just finish this out here. Sorry about the confusion here. 16.5 is equal to the first term, I don't know, 7 minus 1 times 1.5. So 16.5 is u sub 1 plus 6 times 1.5. And we end up with our first term is 7.5. So to find that fourth term now, my u sub n is u sub 1, n minus 1 times d. So that's going to be 7.5 plus 24 minus 1 times my common difference, which was 1.5. And sorry, it won't let me write the 1.5 over there, but the d, oh, there it went a bunch of times. see if we can fix that now. Yeah. Okay, there we go. 1.5 times 23 plus 7.5. Okay, gives me my 24th term is 42. Now, there is one other way that you could do this. It turns out that your d value is the same thing as your slope, because this is a linear relationship. So you could think of these as a point, 7, 16.5, 12, 24. If you actually do the slope with those 2 points, you end up with a slope of 1.5. So I don't know that you necessarily want to try to rely on that. I mean, that method is fine. I think probably they would prefer to see one of the other two there. So you kind of figure out what works best for you. The book is going to do it the way on the left. I think the way on the right is a little bit easier to follow, but if you like the slope, go for that. Too far. Okay, so last question here, and then we get into a little bit of the calculator and then some questions. So a car whose original value was $25,600 decreases in value by $90 each month. How long will it take before the car's value falls below $15,000? Okay, so first, if you have a story problem and you feel like it's a sequence, you need to, first of all, verify what type of sequence it is. So in this case, you're decreasing by $90 each month. Every month, it's the exact same amount. You'd be subtracting to find that new amount. So this is, in fact, arithmetic. So in this case, my first term would be $25,600. My d value is negative 90. And I don't know how many years, but I know that my final value we're looking at here is 15,000. So I'm going to plug that into my formula. 15,000 is equal to 25,600 plus n minus 1 times my d value. And then I'm going to solve this. So I'm going to subtract the 25,600, so negative 10,600. Is equal to, and I'm going to distribute this part right here, negative 90 plus 90, negative 90 n plus 90. So negative 10,690 is equal to negative 90 n, and n is 118.8. Now 118.8 is going to give you exactly 15,000. You want it to be below that, so that would be n is equal to 119 months. All right, now as far as the calculator stuff, let me come back to that in a minute because, like I said, that's just going to be a way of kind of checking your answers. Let's just go ahead and finish the notes here, and then we'll go back to the calculator stuff. And then that way, if you don't care about the calculator stuff, you don't have to worry about watching this part. Okay, so the last part here is about an arithmetic series. So that's just taking a sequence and essentially changing it into an addition question. Now, in the case of this this example here, these were all positives. So they all turn into addition symbols. If they had all been negative, then they would all look like subtraction. So you have two different formulas here for the sum formula, and it kind of depends on the information that you're given. If you do not know the last number, so let's say you want to add up 10 numbers, then your last number is the 10th term. If you don't know the 10th term, then you want to use this first one. And let me see here what I had written on my paper. Let's see, I don't know the last term. Now the other one here, I do know the last term. I think that one's easier to do. There's less numbers to deal with, definitely. So you can find the last term like we did on the previous questions. If I'm going to add up the first 20 numbers, if I don't know the 20th number, I can find the 20th number. And then you can use that second formula. Totally up to you. Okay. And then those numbers all mean the same thing again. So find the sum of 20 terms of the series, -2 plus 1 plus 4, and so on. Okay, well in this case, I don't know what the 20th term is. I could find it, but like I said, I can use that other formula there. So in this case, my n is 20, because I'm doing the sum of 20 numbers. My first term is -2, and my d I can look at if I can get just by looking at it there, would be 3. So 20 over 2, I'm using this first formula right here, is equal to 2 times the first term plus 20 minus 1 times 3. And then I just do the math. So 10, negative 4, plus 19 times 3, excuse me, that's going to be 10 times 53, which is 530. Again, see if that answer makes sense. If you end up with a negative, negative's not going to make sense. Okay. Now, the next one, I actually know the last number. The problem is I don't know what term it is. So I know the last number is negative 16, but I don't know if that's the 10th term, the 20th term, whatever. So I'm going to use the information here that I know. My first term is 10. My D value is negative 2. My last term is negative 16. I just don't know what that number is. So let's find that number. If I plug it into this formula, I can solve it. So U sub n is negative 16, 10, don't know n, negative 2. Okay, so negative 26 would be equal to negative 2n plus 2, and that's going to be negative 28 is negative 2n, and n is equal to 14. So now U sub 1 is 10, n is 14, U sub 14 is negative 16. Now I can use the second formula up here. So 14 over 2, 10 plus negative 16, 7 times negative 6, negative 42. Does that answer make sense? Yes, because the last term was a negative, so there would be other negatives in there as well. So yeah, sure, makes sense. All right, 2 more here. A new business is selling home computers. They predict that they will sell 20 computers in their first month, 23 in the second, 26 in the third, and so on. How many months will pass before the company expects to sell their 1,000th computer? Okay, so this is not exactly a straightforward sum question, but it is a sum. If I want to sell 1,000 computers, think about this. The first month is 20. The second month is 23. So how many computers have they sold total? 43. That's a sum. Okay, so my common difference here would be 3. My U sub n is 1,000. I just don't know when that happened. So we did that there in the last question. I'm sorry, this is different. It's not U sub n is 1,000. My S sub n is 1,000. I know the sum is 1,000. I just don't know what number is giving me that. So I definitely don't know what the last term is. I don't know the last month. I don't know what the last month is. I don't know how many I sold in the last month. So we have to use that first formula for this one. So let me write this down again here where we can see it. N over 2, 2 U sub 1, n minus 1 D. Okay, so n is, I don't know, but I know that S sub n is 1,000. N over 2. 2 times U sub 1, that's 20. Don't know my n, and my D value is 3. All right, I'm going to multiply both sides by 2 to get rid of that fraction. So 2,000 is equal to n times 40 plus 3n minus 3. So that's going to be 2,000 is equal to n times 37 plus 3n. 2,000 is equal to 37n plus 3n squared. So that's going to be 3n squared plus 37n minus 2,000 is equal to 0. Now, I need to solve that. So we're going to use the calculator. So let's switch over here real quick. Oddly enough, that's exactly kind of what I wanted to do here, but we need to start over. So let's go to our apps here. Apps. Let me quit and get back out of this to remind you where this is. Okay, so we go to apps, and you want to go to number 4. And we want to solve an equation, not a simultaneous equation solver. That's going to be when you're doing a system. So we want number 1. Everything on this screen should stay the same. Okay, so my a sub 2 there is what's in front of my x squared, so that's going to be 3. And then 37, and then negative 2,000. And then we solve. And it gave it to me as fractions. Okay, I tell you what, let's see if we can just hit this button here. Will it switch it for us? There we go. That's cool to know. Okay, we can switch back and forth there. So we're talking about the number of months. A negative amount of months make no sense, so we can disregard that answer. So we've got 20.4. Okay, so M would be 20.4. Now, in the 20th month, they have not sold 1,000, so it would be 24 months. Alrighty. Last thing, and then we'll go back and look at the calculator real quick here, is sigma notation. So a sigma is a Greek letter, and in math it stands for the sum. So you might have something like this expression here, sigma from I equals 1 to n of u sub I is equal to u sub 1 plus u sub 2, and so on, all the way up to u sub n. Essentially, this is easier to see as an example instead of generically. So on the bottom number there, that's my index. The index starts with 1 and it goes to 5 of 2 plus I. Well, essentially what I'm going to do is I'm going to plug 1 in, then I'm going to plug 2 in, and 3 in, and 4 in, and 5 in. I'm going to go from 1 all the way up to 5. And I'm just going to plug it into that equation there, the equation being 2 plus I. And then I'll add up all those terms, and I get a sum of 25. So a sigma automatically means to find the sum. Now you can do this 2 ways. Okay, so method 1 is to actually do what we just did there in that example. So it's actually to expand and to write all the terms out. So u sub 1 would be plugging in I equals 1. So that's going to be 5 plus 2 times 1 is equal to 7. U sub 2, that's going to be I is equal to 2. That's going to be 5 plus 2 times 2, which is going to be 9. Now, eventually here you'll notice a pattern because that's the deal with these. 5 plus 2 times 3 is equal to 11. Hey, what do you know? I'm adding 2 each time. So at that point, if you want to just kind of shortcut to, hey, this is going to be 13, and hey, this is going to be 15, that's fine. But now we need to actually add them up. So we're going to do the sum then, and that's going to be a sum of 55. Now, for 5 numbers, that's not bad, especially once you can see the total there, or see the pattern. But what if I was going all the way to 50, which could be a possibility? I don't want to do that method. So let's look at using one of our formulas. Now, personally, I like this formula, and I'm going to use it whenever I can. And let's write it down correctly here. So in this case, if I'm doing the sum of the numbers from 1 to 5, I'm going to find my u sub 1, I'm going to find my u sub 5, and then I need to know how many numbers I'm adding up. Well, u sub 1 is 7, and u sub 5, we didn't do this up above because I kind of cheated, but we would just plug 5 into that formula, and we end up with 15. Now, as far as my number, my sigma is going from 1 to 5, so that's 5 numbers. So now I plug that in, 5 over 2, 7 plus 15, 2.5 times 22 is equal to 55. So this method is good when you've got a large amount of numbers and you don't want to actually have to take the time to find them individually. Now, there is actually another method that I'll show you here in a minute that we can use on this one with the calculator. Now, if you are cool with just doing everything by hand, there's no reason you have to use the calculator. You're done. If you want to see some ways to maybe check your answers in the calculator, okay, let me just show you a couple things here real quick. So first of all, and I'm just going to kind of work through what's on this paper, but I'm going to just go ahead and switch to the calculator so you can read through that. But the first thing that they want you to realize here, and I'm going to use the sequence that they've got going there on there. So let's get out of this. Okay, so we're talking about 5 plus 12 plus, well, actually it doesn't matter. Okay, so let's look at, we've got a sequence where we're going to add 7 each time, let's say. Okay, and then now we're going to add 7 again. And now if you hit enter, it's going to automatically keep adding 7. So this is nice, but you have to keep track of it. So this would be your first term. Now this is second, third, fourth, fifth. It's easy to lose track. So I don't necessarily suggest doing that, but if you do have a computation where you have to keep adding the same number, that'll work. Okay. The next method has to do with switching the mode of the calculator. So you can go to mode here. And depending on your calculator, this will look a little bit different, but you're going to go over here to sequence mode. You've always been in function mode, and now we're going to switch modes up here. Now, when you go to your y equals and you're in sequence mode, it looks a little bit different. So you can actually put 3 sequences in here, a U sequence, a V sequence, and a W sequence. It makes no difference. It's like having a U sub, or Y sub 1, Y sub 2, Y sub 3. That n minimum, you're just going to want that to be 1. Then we're going to plug, sorry, I'm looking at this. We're only going to really be doing that first one. The U, we're not going to put anything in for that use of n minimum. And depending on your calculator, you may not even have that as an option. But here's where we're going to type in our equation. So on your paper, they've got an equation of 127 minus 7n. So 127 minus 7. Okay, now n, if you hit the X button, you can see it lit up there on my screen. It is now going to be an n because in sequence mode, that button is an n. Okay, so now my equation is in here. So what I can do now is I can go to, I can get out of the screen, and I can do more than one thing here now. If I want to know what U of 15 is, U sub 15, okay, in my calculator, I'm going to do this. So to get the U button, you're going to hit second, and you're going to hit the number 7. Now there is a U someplace else, but it's not the same U. There's a U above the 5, but you need this U, okay? And then type in 15, and it's going to spit out 22. That is the 15th term. Okay, so that's kind of cool. You can also go to your table. Now we're starting at the first term, and you can scroll down. Now, it takes a good bit of time to do that, so you can do something else, and I'll show you that here in a second. There's my 15th term is 22. Okay. Now, if you had to go like to the 100th term, you're not going to want to scroll down, obviously. You can go to your table set, which is above window, and you can actually change this. Now, I'm not going to go to 100, but let's look at 15 there again. If I go back to my table now, 15 is now the top one, so I don't have to worry about scrolling there, okay? Now, the next option is to, and this actually doesn't even have to be in sequence mode. In fact, let's go ahead and switch it out just so that you don't forget to do that. Okay, so for this one, we're going to go to our stat. So hit second and stat. And actually, we're not going to stat, we're going to list. And we're going to go over here to OPS. This is for operations. And I'm going to type number 5. Now, this is going to bring up a screen. It should. If it doesn't, then you've got the sequence there of what to type in on your paper. But I'm going to type in my expression. So that was 127 minus 7n or 7x. The letter doesn't matter as long as you put the same letter right here. Okay. What term are you starting with? I'm starting with the first term. What term are you ending with? I'm ending with 15. And how do you want to go? You want to do every term? Then that's going to be step of 1. And then hit paste. And that's, again, what it would look like if you type it in. Hit enter. Okay. Now this is going to list all 15 terms. So 120 is my first term, 113 is my second term. And then if you arrow here, it'll give you eventually that 15th term. Now, if you want to just do the 15th term, now you can do this back on, I'm going to hit second and the enter button to bring back up what I just typed in. And then I can go here and I can change this to a 15. Now, actually, I have to insert a 15. And there's my 22. Now, you could also get that if you don't remember how to do the sequence there. If you go back here again, just put a start at 15 and end at 15, and it will let you do that. Now, the last thing here, those are all the different ways I can find the sequence. But if you want to now find the sum of your sequence, okay, so let's say that you want to find the sum of these 15 numbers. So, of course, you can use a formula, or I can add an operation to the sequence thing. So we're going to go to list, and this is the very last thing on your paper. This time, though, we want to go to math. And you can see there it has a number 5. So we're going to do that. Then we're going to go back and do our sequence again. So we're going to go back to stat and to our operation and to number 5. Okay, make sure, darn it, it cleared everything out. 127 minus 7x, x, 115, I want to go by ones, okay, and hit paste. Okay, so now it says sum of my sequence. I'm going to go ahead and close this extra parenthesis now that was not closed before. I hit enter. And the sum is 1,065. Now, how do I know that that's right? Well, my first term was 120. I can see that in my list. My 15th term was 22. We did that multiple ways. I'm adding up 15 numbers. 15 over 2, 120 plus 22. That's 7.5, 142. And 142 times 7.5 is 1,065. So it checks out. So like I said, that's a good way to check your work, but they're going to want to see you use some type of formula. I would just use it simply to check. All right, so this was a longer lesson because we had 2 parts to go over, plus all that calculator stuff. You're doing homework from section 7.1 and 7.2, just a few problems from each just to make sure that you got the hang of it. Tomorrow's lesson will be over geometric sequences and series, which works very much the same way.